right, we're just going to go over the difference between distance and displacement and how to find the direction of your displacement. So by way of example, let's say that you start some trip here at this green dot. This marks your starting point. And let's say you end up at this orange dot or this red dot or whatever it is, and that's your ending point. And in order to get from where you started to where you ended up, you took a path that looks like this. If I wanted to know what distance you traveled, I would have to know how long this blue pathway is. If you imagine it as a piece of string and I stretch it out and I measure it with a ruler, that would be your distance traveled. So distance is the total amount of ground covered. Your displacement, though, would be something different. Your displacement would tell you, relative to where you started, where did you end up? How far away and in what direction? Displacement's a vector, which means it includes magnitude, how much, in this case, how far, and direction. How would I denote this direction? Well, the arrowhead is pointing in the direction of the displacement. That arrow is how I would represent a vector. So we could call it depends on how we set up the problem and how we defined what was going on here, but we could call that to the right, we could call that east, we could call that positive, or something else. It really depends on how you set up your problem. But that would be your displacement. So what do I know about displacement? It is, it's a vector quantity, so it has magnitude and direction. It is usually, when it's introduced, represented with the letter S. We will oftentimes, for displacement, represent it as a delta X or a delta Y. And if you don't remember, if you're not familiar, that triangle is the Greek letter delta. And X for us is going to stand for position. And delta is read as change in. And X would be position. So delta X you could read as change in position. And delta Y is also change in position. We, by convention, people will use delta X if they're talking about a displacement that's horizontal. Think about the X-axis on a graph. And they'll use delta Y if there's a displacement that's vertical. And you can just think about your graph axes. So that is how displacement's often represented. So we'll represent it with an S sometimes, and often with a delta X or a delta Y, and you'll get used to it. Another thing to think about in terms of displacement, let's say that this is you. Let's say that you're running. You go for a jog in the morning. And you leave your house and you follow this path. So you go for a little run around town and then you end up right back at your house. So your starting point is here and your ending point is here. You start and end at the same point. So what is your displacement relative to where you started? How far away is your ending point? Well, it's the same position. It's the same place. So your displacement here would be 0 miles. If you went for this run, let me just get a different color here. And you followed the same path, right? And you ran this whole distance and you stopped right here, and maybe you stopped, 10 feet away from where you started, your displacement would be 10 feet to the left. It wouldn't matter. You don't take into consideration the rest of this path you took. All you care about with displacement is where did you start and where did you end. And that is all that matters with displacement. And now we're just going to talk a little bit about direction for displacement. All right, so let's say, once again, you start here as your starting point, this green point, and we'll make an orange point your ending point. So you end up here. We're going to see, once you set up these problems, you're going to see that they're really just right triangle problems. That's what these initial problems are always going to end up being. So finding the magnitude of this displacement, how far away are you, is not going to be very hard for you guys. And we're going to see that you're going to have to find an angle also, and that's just your trigonometry, right? Triangle trigonometry, and that's not very hard. What is probably going to mess you up, if anything does, is finding out what's the direction. What is the direction of your displacement? Because you're going to have to give that information. So to find your direction, remember you started at the green point and you ended up at this orange point. We're going to just use our compass points in this case. We could use... there's other ways you can do this, but we're going to use compass points. And we know that our compass points are north, south, east, and west. And we can clearly see that this, relative to where you started, if you put where you started in the middle, in what direction should you head if you want to get to the ending point here? And you should certainly head northeast. It's in this northeast quadrant here. But you can't just say northeast. If you find out, let's say you calculate that this is 10 miles. You can't just say, hey, I'm 10 miles away northeast, because that would be anywhere along this arc, right? It would have to be 10 miles long, but it would be anywhere. This is all northeast, this whole thing here. So you want to give an actual angle. You're going to actually find this angle here, and which is just right triangle trigonometry. You're not going to have problems doing that. And let's say you find out that this angle is, well, it doesn't even look like 50 degrees. Let's say that this angle is 25 degrees. So you calculate that that's 25 degrees, and you still can't say I'm 25 degrees away northeast. Why can't you say that? Because we could see when I draw this yellow line, there's two angles that are formed. There's this pink angle here, and let me draw it in a different color. I'll draw a blue angle. There's also this angle here, and this angle we know would be, I'll put a little C there, that would be the complement to that angle, because these add up to 90 degrees, right? Because north is 90 degrees, oriented 90 degrees relative to east. So if I want to denote that it's this pink angle I'm talking about and no other angle, what am I going to do? How am I going to give that information? I'm going to say that relative to east, you want to go north. This angle here is a north of east angle. And that would make this angle here, if I wanted to make this complementary angle. This angle here would be relative to north. You'd want to go east, and this would be an east of north angle. If we take another example, let me put an angle somewhere else here. Put one here. If this were my displacement, there would be two angles here, right, in the southwest. If I wanted to talk about this angle, what would this angle be? Well, from west, I would have to go south. This would be a south of west angle. And if we wanted to talk about the complement, if we want to talk about this angle here, from south, I would go west. This would be a west of south angle. So one of the things that you see on the web page is a drawing. Let me put up that drawing. So here is that drawing from the web page, and this is just showing you where these angles are. So again, what do you need to remember? You need to remember that whatever your starting point is, that's in the middle, and wherever you end up, you're going to give the direction relative from where you started to where you ended up. So if I wanted to start at the blue point and end up at the red point, in what direction would I have to move? Well, if you calculate this angle, you're going to say you have to move at this angle north of east. If you calculate this angle, you're going to say you have to, travel a certain distance at this angle east of north.